Okay, let's move on to part B here. Same situation. A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away, still at a rate of 2 feet per second. Now the question becomes, how fast is the area of the triangle changing when the base of the ladder is 7 feet from the wall? So again, still the right triangle, and we're talking about this area of the triangle inside. So the area of a triangle is equal to 1/2 base times height, or in our case, we could define it as 1/2 x times y. Rate of change of x is still 2 feet per second. We're still dealing with the ladder 7 feet from the base of the wall. We still have a length of 25 feet, that's constant. In the last part, we identified that dy dt is equal to negative 7/12 feet per second. The reason we can use that value is because that's the value when x is 7 feet from the wall. And since it's still 7 feet from the wall, we can still use that negative 7/12 feet per second, and we can still use the y equals 24 feet. Again, x and y are changing, so we will not be able to plug those into our equation until after we take a derivative. So here we go, derivative. Of our area equation. A equals 1/2 xy. There is no way around the fact that x times y is a variable times a variable, and that's going to give us a product rule. The 1/2 is a constant coefficient. We can ignore that till after we take our derivative, plug all our values in, we can get a numeric answer, and then we can multiply it by 1/2. So, our derivative, fraction, 1/2. Go through your product rule. Product rule says first variable, first multiplier, times the derivative of the second. So that's going to give us a dy dt plus our second factor, y, times the derivative of our first factor, which is going to be dx over dt. And there's our derivative, ladies and gentlemen. 1/2 times x dy dt plus y dx dt. We know x is 7 feet. We know dy dt is negative 7/12 feet per second. We know that y is 24 feet. We know that dx dt is 2 feet per second. So we're going to be able now to plug all of those values in. Again, we've got a 1/2 multiplier out in front. We're going to multiply 7 feet times, we're going to need a fraction here. We're going to have negative 7/12 feet per second plus our y is 24 feet times our dx dt, which is 2 feet per second. If you hear a little whining in the background, that would be my Labrador Retriever Shadow, who is a little bit upset that the neighbor is outside cutting his grass. So we're going to multiply these things out. We're going to get fractions. I don't propose that it's going to be a pretty answer in the end here. New equation, fraction, we'll keep our 1/2. Seven times negative 7 will give us negative 49 feet squared. 49 feet squared over 12 seconds plus 24 times 2. Go ahead and do this as a fraction as well. It's going to give us 48 feet, again squared, per 1 second. And we're going to need to find a common denominator, which is going to be 12. And we're going to go ahead and switch screens here. We're going to do 48 times 12, which is going to give us 576. So we're going to end up with 576 minus 40 and negative 49 equals fraction. See if we could fit this all in here. 1 over 2 parentheses. 576. It's going to give us what? 527. 576 minus 49 is going to give us 527. Still feet squared. And that's going to be over 12 seconds. And when we multiply that together, it's going to give us 527 over 24 as a final answer here. So we will have dA dt . 527 feet squared over 12. Seconds. And if we jump back here, we should be able to look and see what the correct answer is. Here it is, 527 over 24 feet squared per second. So we do have the correct answer there. Not a particularly difficult problem. Most tricky thing in this is to recognize the product rule, x times y, and to apply the product rule correctly, and recognize that we're still dealing with 7 feet from the wall. So everything we found for 7 feet from the wall in part A will still be able to be used in this problem. And I believe when we get to part C, which talks about the angle between either the ladder and the ground or the ladder and the wall, one of these two angles, when we get to that problem, it should also be at 7 feet, so we still will be able to use all the same numeric values. So getting that first part right becomes very important. So that's it, and shortly we will upload another video of part C. Thank you very much.